All right, so we're going to talk about section 3.1 tangents and the derivative at a point. And you can see in the notes like that I said, I put a study tip in there, and I said to find a tangent at a curve at a point P and a nearby point, we're going to use the same process as in section 2.1. So this is going to seem exactly the same thing, except we're going to put a limit in front of what we're doing, whereas before we didn't have that limit there, but what we were doing was really taking a limit. But it's really going to be the same thing because we were talking about a point and then a nearby point, and we did that in section 2.1 where I drew the graph of a function and we had a point x, and then I said then we're going to take another point near it and just call that x sub 0 plus h. So really it's kind of the same thing. And then we're going to find the limit of the slope as h approaches 0. So as that h gets really small, we're talking about that distance between those 2 points getting really small. So here's our definition. The slope of a curve at a point, x sub 0 comma f of x sub 0, is going to be the number m. So m is going to be our slope. And still doing the same thing that we did where we talk about the rise over the run or the change of the y's divided by the change of the x's. But now we're just saying that we're taking the limit as h gets really small. So we were doing that before, we just didn't say that it's going to be the limit in front of it. And the tangent line to the curve at P is going to be the line through P that has this slope. So let's take a look at this first example. So let f of x be equal to x cubed minus 1. And let's find the slope of the tangent line at x is equal to 2 and then write the equation of that tangent line. I think I'll go to this here. So we have f of x is equal to x cubed minus 1, and then we want the slope of the tangent line at x is equal to 2. So when x is equal to 2, f of x is equal to, so if we, at that point 2, our y value of that function is going to be equal to 2 cubed minus 1, so that's going to be equal to 7. So from our definition, our slope m is the limit as h approaches 0 of f of x sub 0 plus h minus f of x sub 0 divided by h. So since our x sub 0 is 2, I can plug 2 in here for x sub 0, and we have the limit as h goes to 0 of f of 2 plus h minus f of 2 divided by h. All right, so now what we're going to do is we're going to take this 2 plus h and we're going to plug it into the function f. So wherever we see an x, we're going to plug it into the function f. So that means that we're going to be taking 2 plus h and we're going to be cubing it. So just to recall how to cube a binomial, so if we have a plus b cubed, we're going to be cubing the a and cubing the b at the end, and then the middle two terms are going to be 3 times a squared times b plus 3 times b squared times a. So it ends up being a cubed plus 3a squared b plus 3ab squared plus b cubed. So that's just for you to recall. So now let's look back at that limit. Well, let's do this off to the side. Let's do f of 2 plus h because it's a little bit of work. So because we have to plug that back into our limit. So let's just take care of that. Let's plug that 2 plus h into our function, and we get 2 plus h cubed, and then we have to subtract 1 from it. So using our little formula here for cubing that binomial, we know that it's going to be 2 cubed plus 3 times 2 squared times h plus 3 times 2 times h squared plus h cubed, and then we still have to subtract the 1 at the end. So simplifying that, we get 8 plus 3 times 4, that's 12h, plus 6h squared, plus h cubed, minus 1, and then we can just do the 8 minus 1, and then we end up with 7 plus 12h, plus 6h squared, plus h cubed, minus 1. Not minus 1, thanks. So let me erase that. Yeah, definitely not minus 1. All right, then we're going to take this, what we just did here, and we're going to go back to our limit right here, and we're going to plug this, the 7 plus 12h plus 6h squared plus h cubed, into our limit. So I'm going to do that on another page. Okay. So now I'm just going to copy this over so we know what we're doing. You guys already have this on your paper. So we have the limit as h goes to 0 of f of 2 plus h minus f of 2 divided by h. And then we just found that to be the limit as h goes to 0 of, and we have 7 plus 12h plus 6h squared plus h cubed. And then f of 2, we have to subtract f of 2, and we said previously that f of 2 was 7, so we're going to subtract 7 now because that's what f of 2 is, and then we're going to divide that whole thing by h. And then you can see in that numerator we have 7 minus 7, so those two things are going to cancel. And then the rest of the three terms in the numerator all have an h in them, so we can factor that h out of the numerator and get the limit as h goes to 0. So we factor out h and we get 12 plus 6h plus h squared divided by h. And we can cancel an h in the numerator and in the denominator. And then what is our limit going to be as h approaches 0? So what do we do with the 0? Plug it in, right? So as long as there's not any problems with the denominator being 0, which there isn't because that h canceled, so that's always our goal, is to try to get rid of that factor in the denominator that causes division by 0. So now we can plug that 0 directly in, and this limit is going to be equal to 12. All right, so what does that mean? What is that 12? The 12 is what in terms of this problem? What does it represent? It's a slope, right? Right here? Yeah. That's a 12. Oh, sorry. Yeah, so it's this 12 right here. It's just a little messy. All right, so that limit, which is 12, represents the slope, and it's a slope of that function x cubed minus 1 at that point. And so we found the slope, and then we also have to write the equation of the tangent line. So how do we write the equation of the tangent line? Same as what we did before. So we're going to use that point slope formula. Because we have a point, we know that we have a point when x is 2, y is 7. So we have the point 2 comma 7, and we also have a slope. The slope is 12. So we can use a point slope formula, which is y minus y sub 0 is equal to m times x minus x sub 0. And then we can fill the value in for the x and the y. So we get y minus our y sub 0 is 7. And that's equal to our slope m, which is 12, times x minus x sub 0, which is 2. And then if we're asked to write it in slope-intercept form, we can just solve this equation for y. So this is going to be the same thing as y is equal to, when we distribute the 12 on the right-hand side, we get 12x. And then that's going to be minus 24 plus 7. So you have this minus 24 plus 7. So this is going to be the same thing as minus 17. So that's going to be the equation of the tangent line at that point. So if we're looking at the graph of x cubed minus 1, it's the graph of x cubed, and it's shifted down 1. So normally x cubed goes through the origin, but x cubed minus 1 will look like this. And we're looking at the point 2, 7, so point right here. We're looking at the slope of that tangent line at that point. So we can draw a tangent line in there. And the slope of that line is going to be 12, and then the equation of that line, of that tangent line, is going to be 12x minus 17. Okay, does that make sense? Any question on that? Okay, let's go back to the notes here then. And let's look at rates of change, and now we're going to call it a derivative at a point. So this is the first time I think we're talking about a derivative. And here's our definition: the derivative of a point f at a point x sub 0, denoted f prime. So the way that we denote, one of the ways that we denote a derivative of a function is by using this prime symbol after the function name. So f prime at x sub 0, f prime of x sub 0, is going to be the limit as h goes to 0 of f of x sub 0 plus h minus f of x sub 0 divided by h. That look familiar? It's the exact same thing that we've been doing, right? That derivative at that point is going to be the slope. It's the same thing, but now we're going to be calling it a derivative. And so we've kind of been doing this so far this semester. And different interpretations for the limit of the difference quotient. So we've kind of done these different interpretations for this. It's the slope of the graph at a point. So I just showed you an example of that, how we're going to do that. Which is also the slope of the tangent line to the curve with respect to x at that point. So those are kind of the same thing. It's also a rate of change. So anytime we're talking about a rate of change or how something changes, we can talk about a slope. And now we're going to be calling it the derivative. But they all are the same thing. All right, so what is the rate of change of the volume of a ball? So there's the formula for the volume of a ball or a sphere. V is equal to 4/3 pi r cubed with respect to its radius when r is equal to 2. So we're talking about a rate of change of something. That's the same thing as talking about the slope of something, which is the same thing as talking about its derivative. So we're going to use the same formula that we just used. So I'm going to go back to one of these pages here. So we're looking at the volume of a ball, which is 4/3 pi r cubed when r is equal to 2. So we're looking for a rate of change. So again, we're going to look at the limit as h goes to 0 of f of x sub 0 plus h minus f of x sub 0 divided by h. And then just like with the last problem, since our r is equal to 2, r is our variable now. It's not x, but r. So we can plug that 2 into this function just like before. And this is the limit as h goes to 0 of f of 2 plus h minus f of 2 divided by h. All right, then what are we going to do with the 2 plus h? yeah, we're going to plug it into this function. So even though I didn't call the function f here, but I could have wrote this function as f of r. I could have said that this function is called f and the variable is r. It's 4/3 pi r cubed. So that's what our function is. So we're going to plug that 2 plus h into that function. So again, I'll do that off to the side. So f of 2 plus h. So I'm just doing this part of it first, just this initial part of this limit. So plug that in here and we get 4/3 pi, and we want to cube that 2 plus h. All right, so this is going to be 4/3 pi times, and we have to cube 2 plus h. We already did that in that last problem, so it's exactly the same thing as what we did before when we cubed it. So we cubed the 3 and we got 8. And then we did 3 times 2 squared times h. So that was going to be 3 times 4, so that's plus 12h plus 3 times 2 times h squared, so plus 6h squared. And then we cube the h at the end. And then that's equal to, we can distribute the 4/3 pi. Well, actually, let's just leave it maybe like that. Yeah. We can just leave that like that. All right, then let's do f of 2 because we need this part as well. So f of 2, when I plug 2 into the equation, I get 4/3 pi times 2 cubed. And that's going to be 4/3 pi times 8. All right, now let's go ahead and plug those back into our limit that we have. So we're looking at our limit as h goes to 0. And we're using the same thing that I wrote up here. We're plugging everything back into this limit. So f of 2 plus h. So that's going to be 4/3 pi times 8 plus 12h plus 6h squared plus h cubed minus our f of 2. So that's going to be minus 4/3 pi times 8. And then we're going to divide that whole thing by h. So you might be wondering like why I didn't distribute this 4/3 pi inside the parentheses and why I didn't multiply 4/3 pi times the 8. And I didn't do that just because I knew that it was going to be a common factor in each one of these terms in our limit, and we would probably want to factor it out at the end anyway. So now we can see that it's a common factor, and it's easier for us to factor out that 4/3 pi here. So it's a common factor here, and it's a common factor here. So we can factor that out. So this is equal to the limit as h goes to 0 of 4/3 pi times 8 plus 12h plus 6h squared plus h cubed minus 8 and still divided by h. And then inside the parentheses, we have 8 minus 8, so we can cancel those. And this is always going to happen. You're always going to have something that's going to be canceling in these. And the whole point is that we're going to be able to also factor out an h so we can cancel that h in the denominator. And then does everybody have this written down so I can get a new page here? Right, so let's continue that. So that's going to be equal to the limit as h goes to 0 of 4/3 pi. And now we can factor out an h because all the terms that we had left in the numerator have an h. And after we factor out the h, what's left is 12 plus 6h plus h squared divided by h. And now we can cancel the h's. And now if we're taking that limit as h goes to 0, now we can plug that 0 in for h. So this 0 goes into this limit for h. And what we have left is 4/3 pi times 12. So this is 4/3 pi times 12. And the 3 will cancel here. We can get a 4 here. And that's going to be equal to 16 pi. So that's going to be our rate of change. So the rate of change is the slope. It's the derivative. It's this limit that we find as h goes to 0.
How did you just get to 4 pi over 3 times 12 at all?
I took the limit. So I took the limit of this thing, which means I'm going to plug h into this function. So everywhere that there's an h here, I plugged in a 0. So plug in a 0 here, plug in a 0 here, and that's what's left. All right, then what I want you to do is after you finish looking at this problem and you're happy with this one, take a look at the next problem on the page about that object being dropped from the 100-meter tower. Go ahead and try that one. It's going to be similar to this one. All right, let's take a look at this and see how you did. So again, we're finding that limit as h goes to 0. And x is 2 again, so we're looking at f of 2 plus h minus f of 2 divided by h. And here I did, off to the side, I did f of 2 plus h. So I took the 2 plus h and I plugged it into the function wherever I saw a t. And I ended up with 80.4 minus 19.6 h minus 4.9 h squared. So hopefully you got that. And then the other thing that we have to find is the f of 2. So I did that off to the side here. And for f of 2, I got 80.4. So then we're going to go back to our limit here and we can plug everything in that we just found. So we're looking at the limit as h goes to 0. And now I have to write f of 2 plus h, this thing that we found over here, which is 80.4 minus 19.6 h minus 4.9 h squared minus this 80.4 minus 80.4. And then we're going to divide that by h. Every time we're going to have something that cancels in that numerator, so if you don't, go back and look at your work and see if you made any error. Those 80.4s cancel. And just like before, the rest of the terms have an h that we can factor out. So we have the limit as h goes to 0, factor that h out and get negative 19.6 minus 4.9 h divided by h. The h's cancel. We can take the limit as h goes to 0. So we're going to try and plug that 0 in, which we can do. And our limit is equal to, so negative 19.6. And what does that negative represent? Why is it negative? Does that make sense? So it's the direction. It means that that object is falling. So the object is falling at 19.6, and then what are the units going to be in this one? So meters per second, right? Okay. Any question on that? All right, I want to do another example that's not in your notes, but this one will help you with your homework a little bit, so you'll have to get out a separate piece of paper for this. So here's the problem. Let's find the point. So already we're looking at something different because we're finding a point. The other ones we were finding a rate of change or an equation of a tangent. But now we're going to find the point, x comma y, at which the graph of y is equal to 6x squared plus 6x minus 8 has a horizontal tangent. So if we were to graph y is equal to 6x squared plus 6x minus 8, in general, what is that graph going to look like? What type of a graph is that? It's a parabola. So it's x squared. It's going to be a parabola, shifted away from the origin, of course, but it's a parabola. So it'll look something like this. Okay. And we're looking at a horizontal tangent, but it is a tangent. So we're still going to be interested in the slope or the rate of change. So we're still going to use this same definition where the slope is equal to the limit as h goes to 0. Same thing we've been using, f of x plus h minus f of x divided by h. All right, so now we have to find f of x plus h. So how are we going to find that f of x plus h? How do you find x plus h? We don't have an x, this one, because we're finding that point x comma y, but what do we do with the x plus h? Plug it into the equation, right? So we're going to find f of x plus h, and then we're going to subtract f of x from it. So again, we can do that maybe off to the side where we find f of x plus h. And we're going to take the x plus h and plug it into this equation, into our function f. I could have written this as f of x here. All right, so we have 6 times x plus h squared plus 6 times x plus h minus 8. And then go ahead and simplify this. Find that slope in the same way that we've been doing. So go ahead and do that on your own. And after you get that, plug it in and subtract the f of x, and then simplify that whole thing just like we've been doing. All right, is everybody caught up to this point where you found f of x plus h minus f of x? So just be careful with that subtraction because we're subtracting the entire function f of x. So after I write out the whole f of x plus h part, I have to subtract this function. So all of these signs here at the end become the opposite of what we started with. It's minus 6x squared minus 6x plus 8 because I'm subtracting that function. Because I'm subtracting the entire function. So instead of writing that out in 2 steps where I'm saying I'm subtracting this function and then distributing the negative, I just wrote it in 1 step here instead of writing it as 2 separate steps. All right, so now we can simplify this thing. We see we can cancel the 6x squared. We have 6x squared minus 6x squared. And then we have 6x minus 6x, and then we have negative 8 plus 8. So you're always going to have stuff to cancel. So like I said before, if you don't have stuff to cancel, go back and look and see what you might have done wrong. All right, does everybody have this? I can go to another page here. Because what are we going to do at the next step? So yeah, we're going to cancel that h. So we're going to factor out an h on the next step here. So the next step, you should have gotten a limit as h goes to 0, factor out that h, and then what you're left with is 12x plus 6h plus 6 divided by h. And then we can cancel those h's. Is that what you got? Should be a minus in there, shouldn't there? Or no? Nope, that's it. Okay. Now the limit is going to be equal to what? Yeah. So plug that 0 in for h and you get 12x plus 6. All right, so what does that represent? That's our slope. So we're saying that our slope is equal to 12x plus 6. Okay. But we're not given a specific value of x. But we're told in this problem to find the point xy at which the graph of that function has a horizontal slope. Not a horizontal slope, it has a horizontal tangent. So I graphed this thing before, just kind of a real quick graph. This is our parabola right here. And the graph has a horizontal tangent. All right, so parabola, where is a parabola going to have a horizontal tangent? So if I draw a tangent line, where am I going to draw a tangent line that's going to be a horizontal line? It's going to be a horizontal line. So I didn't really intend for it to look like it was at 0, but it's going to be at the vertex of this parabola, right? Because this parabola, it's not going to really be 0, but it's going to be here, right? So the graph is going to have a horizontal tangent when, what is the slope of that horizontal tangent? And in general, when I'm drawing a horizontal tangent, any horizontal tangent, what is the slope? 0, right? So the slope of a horizontal tangent, the slope of that line right there is going to be 0. So the slope of a horizontal line is 0. Slope of a horizontal tangent is 0. So when m is equal to 0. But we know that m is this, but we know that m is also equal to 0. So we're going to set our slope equal to 0 because we know we want the horizontal tangent there. So we're going to say 12x plus 6 is equal to 0. So we're not just arbitrarily setting it equal to 0. It's because that's what the slope of a horizontal tangent is. Oh, missed the x in there. All right, so let's solve this equation for x. So 12x is equal to negative 6, and x is equal to negative 1/2. So we need to find the point, so we need to find x comma y. We have x. So then what do? Plug it in. So now find y. So going back to the original function, y is going to be equal to 6 times, and this is the original function on the previous page that I had here, times negative 1/2 squared plus 6 times negative 1/2 minus 8. So this is going to be 6 times negative 1/2 squared is negative 1/4. And then 6 times negative 1/2 is minus 3, minus 8. And 6 times negative 1/2 is negative 6/4, or negative 3/2. Minus 11. And since I'm going to be subtracting 11, I can just write that with a common denominator. So 11 is the same thing as 22 over 2. So y is going to be equal to negative 25 over 2. Do you agree with that? Yes? No? No? You got a different answer? When you put in your calculator? Well, you shouldn't have an h because h is going to 0. So we have to take the limit of this thing. So we plug 0 in. So that h is going to go away. Oh, yeah, I know for sure that it has to be a +6. So yeah, I'm sure, I'm positive. Yeah, I know that it has to be a +6 at the end. Is it this one here? This one, right? No. This, the one that's a 7 here, maybe? Let me pause this here so we can take a look at this. So everybody agrees then that the ordered pair for this one is going to be -1/2, comma -25/2. And that's going to be the ordered pair where the tangent line has a slope of 0. So, I mean, it's not 0, negative something. It's going to be -1/2. It's not exactly on that y-axis. I mean, I didn't draw it exactly, but it's going to be a -1/2, -25, 2. Okay? Any other questions about this one? Oh, I won't get rid of it.